Hello everyone, I hope you are doing well. I'm Vinay this side, and I've started this channel content creation just to share my journey, my learning, and my daily progress, just to track and I can share my experience, my knowledge with you. Um, you can post your comment. I will reply to you. So let's get started. So basically today is 21st March and I wanted to post this video. It's already been a bit delayed from my side, and yeah, so today going forward on a daily basis I'm gonna post daily progress video. And so from 21st March to uh, till last March. This is the kind of a trial version, but from 1st of April, I will post my daily learning, daily coding, or whatever I am doing, notes through video, through tutorial, whatever way possible, be it creating a slide or anything else, will definitely share to you guys. And this is a way to communicate with like-minded people. And yeah, so today I want to share um, the whatever things I have learned. So basically I started learning Java more or less. I have covered pretty much all the topics, just covering some of the topics where I am lagging behind. So today I prepared the note for it. Let me quickly share my screen. As you can see, okay, so let's see what are the things I have learned today. So first thing is final variable. um, so basically final variable we can use in Java in three ways: find as a final variable, as a final method, and final class. If it's a final variable, it creates a constant variable. That means you cannot change the value of this variable. If it's a final method, it prevents method overriding. If it's a final class, that prevents method inheritance. This is the final keyword in Java. Remember, final is a different and final is a different. Okay, coming back to inheritance, we have different types of inheritance. The first, starting with single. This is a single inheritance means one parent, one child. As simple as that. In a single inheritance, a subclass is derived from only one superclass. It inherits the properties of the behavior of a single parent class. Okay. Multi-level means there are subsequent parent and one derived class. Basically, one base class, intermediary classes, and then derived classes in a single chain. This is called multi-level. Level, you can say. Hierarchical means one base, multiple derived classes. Multiple inheritance, which is directly not supported in Java, but we can use it using interfaces. It's not allowed with the classes. Two bases, two base, one child. This is these are the two bases, and this is a child. So basically, these A and B are interfaces, and C is a class which implements A and B, right? Hybrid, only one possible. Okay, so again, hybrid is also a combination of multiple and hierarchical. As you can see, this is a child class which inherits B and C, and again is a parent. You can say grandparent. But yeah, again, this is possible with the interface. Okay, what is inheritance? Now coming back to here, important feature of OOPS, object-oriented programming. It is a mechanism in Java in which one class is allowed to inherit the feature, fields, and method of another class. Why do we need inheritance in Java? Code. It provides code reusability, method overriding, and abstraction. Okay, I hope you are clear with code reusability, method overriding, and abstraction. If not, if you have any doubt, please comment in the video. I will definitely reply you guys. Now, uh, polymorphism in Java. Okay, what is a polymorphism? Java supports polymorphism by two types. One is a compile time, which is also called static or overloading, and another one is a runtime or dynamic method overriding. So two types of polymorphism in Java. So basically, now coming back to the, let's go with first compile time, static or method overloading. What do you understand by method overloading? So method overloading is something, let me recall it. Method overloading, overriding is a polymorphism concept which is applicable for the inheritance. Method overloading is an inheritance concept. So basically, in Java, method overloading allows different methods to have its same name but different signature, where the signature can be differ by the number of input parameter or the type of parameter. So method overloading also compile type polymorphism, static polymorphism or early binding. In method overloading, compared to the parent argument, the child argument will get highest priority. So basically, this is a program to illustrate my method overloading. So basically, what we are doing here, we are creating a class sum. We have overloaded a method sum based upon the number of arguments. So as you can see, this is a sum. Takes takes no argument. Public int sum, it takes two argument, return the sum of them. It takes two or three argument, return sum of them, and it takes again it takes two argument, and return type is also different here. So again we are calling the sum and appropriately passing the argument, and it will return the value. So in Java, method overloading allows different methods to have a same name but different signature, where the signature can differ by the number of input parameter or the number of input parameter or the type of input parameter, but or mixture of both. It's not method overloading is not on return type. It should be on number of parameter and type of and the data type of those parameter. We can mix these two things. This is a compile time binding, static binding or early binding. Now coming back to the method overriding in Java, okay, dynamic binding. Method overriding in Java occurs when subclass provides a specific implementation for the method that is already defined in superclass. Method overloading method in the subclass must have the same name, parameters and the return type as the method in the superclass. This allows subclass to modify extend behavior of the inherited. Method overriding in Java occurs when the subclass provides a specific implementation for a method that is already defined in its superclass. The method overriding in the method overriding in the subclass must have the same name, parameters, and return type as that of method in the superclass. So basically, it's what can I say? It's an inheritance concept where base class method is overridden by uh, child class. Now at the runtime, based upon the reference type, we can call the object of child or parents. So the key rules for method overriding: method signature name parameter must be exactly same as both in superclass and subclass. Return type must be same of both subtype, covariant type. Access modifier of the method overriding method cannot be more restrictive than the overridden method. Okay, so basically, base class parent class should have less restrictive method then with respect to overridden. If superclass method is protected, then the subclass method can be protected or public. So we have to be less restricted on the base class, right? Okay, only inherited methods can be overridden. Only inherited methods can be overridden. ठीक है, method declared as a final or static cannot be overridden. ठीक है, that's fine. Constructor cannot be overridden. If a class extends a abstract class or implements an interface, it must be override by all the abstract method unless class itself declare abstract. starting how we have done it. So we have created a one method which is show and which is printing parent show. Here we have class child extend parent. Okay, that's fine. We have overridden the show method. Now we are creating a parent object, and with the parent reference is received by parent reference, we are calling show. It will call the parent show. Now if the parent type reference if a parent type reference refers to a child object, child's show, it is called this is called runtime ball version. Here we are creating a child object which is referred by parent, but we are calling the show. But this time this child of the show is called, this is called a runtime polymorphism or dynamic binding, or yeah, pretty much that's it. Let's see these two images, what they are meant to be. Why do we have to give a name, like basically this is the method overloading. This is sum int xyz int xy. We do not have to give name like sum2. Thanks for method overloading. Yeah, that's right. Method loading is typically achieved by changing the number of arguments, changing the data type of argument, a mixture of two. We cannot do method overloading by only by changing the return type. This is important thing to remember, guys. If a method with exact data type is not found, then the automatic type conversion happens. Okay, this is few points related to Java collection implementation of data structure. So basically we have five different categories of Java collection. One is list, set, queue, dequeue, map. So list it provides classes like array list, linked list, vector, stack. Array list, linked list, vector, stack. Remember. Set, hash set, tree set, linked hash set. Queue, stack, linked list, array queue, priority queue. DQ, linked list, array DQ. Map, hash map, tree map, linked map. Collection classes, implementation of for basic algorithm: binary search, short, max, min, reverse, fill. So these are the collection implementation: binary search, short, max, min, reverse, fill. Collection hierarchy, you can see the iterable is the top interface. Then we have a collection which is also a interface: list, queue, set, dequeue, sorted set, map. These are interfaces. Sorted map is also interface. Now coming back to classes: array list, linked list, vector, stack, array dequeue, priority queue. So basically for the list, array list, linked list, vector, stack. For the dequeue, it's a array dequeue. For the queue, it's a priority queue. For the sorted tree, it's a tree set. For the set, it's a hash set and linked hash set. For the map, it's a hash map and tree map. And this is the collections is a different class. Okay, so iterable, collection, list, queue, set, map is a different thing altogether. Everything is coming on java.util.arraylist, java.util package based upon. Streams in Java: no storage, pipeline of functions, laziness, can be infinite, can be parallelized, can be created from the collection, arrays, files, lines, methods in a stream, int stream, etc. So basically source, intermediate, terminal. uh, Class GFG, public static void main string args, list integer L, array list, arrays dot list 5 10 20 30, L dot stream. Basically here we are creating first array list of these integers, then we are applying a stream, L dot stream dot filter dot filtering the even number, then again filtering with those which are greater than 10, and then for each we are printing it on the terminal. Okay, so this is pretty much it. Now coming back to the lambda expression. So this is a kind of one generic functional interface which is a predicate, abstract, class GFG, static void, print condition, collection, enter integer, predicate integer p. For integer x, c, if p dot test x, system dot print x plus, public static void main string args, collection my predicate even, implements predicate integer, a naive code without lambda expressions. Public boolean test integer x, return x by 2, list integer al new array list arrays 10 5 20 7 30 print condition cal new predicate. Okay, lambda special syntax single line void lambda, no parameter syntax finalization or put a single parameter p or p multi-parameter p1 p2. The streams application where we write a code in stream, we take source intermediate operation terminal operation readable short and efficient code, works great with the lambda expressions and method reference, can be parallelized. Java stream examples, example 1 sum of array. What we are doing here, Java streams, basically we are creating arrays dot streams with arr and applying dot sum and we are getting sum here. Okay, that's cool, that's cool. Stream hierarchy and methods, base stream, int stream, long stream, double stream, int stream, generic. Base stream, parallel, sequential, unordered. Methods in the four sub interfaces: filter, for each, main, max, skip, find first, count, distinct, shorted, reduce. Methods only in the first three interfaces: sum, average, boxed. Now coming back to three things. Three okay, so okay, guys, this video is kind of large. I will try to make 5 minutes video on a daily basis, but bear with me. We are on the last topic, which is string buffer and string builder. Let's see why we are using this Java, which one to use in which condition, and which is efficient in which conditions and all. So Java string, basically it's a way Java strings are immutable. What does immutable mean? Immutable objects, is an object whose state cannot be modified after it is created. In Java, this concept is applied to a string, which means once it's created object, its content cannot be changed. If you try to change the string, a new string is created instead. So basically we have public class main, public static void main string args. Basically we are creating, now we are assigning s1 to s2, though s2 points to the same knowledge. So now again here we are concreting base s1 with base, so create a new okay. Why are Java string immutable? Basically an immutable object is an object whose state cannot be modified after it is created. In a Java, this concept applies to a string, which means that once the string object is created, its content cannot be changed. If you try to change a string, a new string object is created. Okay, so basically the knowledge here is s2 is pointing to the same string reference of string pool where the knowledge is being referred. But if you are trying to modify the content of string, the new string is on knowledge base is going to be created. So okay, that's fine. Now why are Java string immutable? String basically it's in Java store a string in string literals in a pool to save memory. Immutability ensures that one reference does not change the value of other pointing to the same string. Security: strings are used for sensitive data like username and password. Immutability prevents attackers from altering the value. Thread safety: since the string values cannot be changed, they are automatically thread safe. That's fine. Efficiency: string buffer in Java. So basically string buffer is a thread safe class. Here it is a mutable, so that means if you are trying to update the same object, it will not create a new reference or new memory every time. So it is a memory efficient, allowing you to modify the content of a string without creating a new object every time. So like it has a multiple and it is a thread safe, efficient, with string buffer, and yeah, it is a mutable. As you say, string is immutable, but this is a mutable. So it is a synchronized, thread safe, as you can see. It provides a lot of method: append, use to text, use to add the text at the end of the existing text. So basically if we create a new object and if we call the append, it will create a first empty string, that then here it append the hello, now the space and the world, so the output would be hello world. Okay, For printing it, we are converting it to toString. So basically, string buffer implements toString method, which overrides toString method, using which it's printing the content. And this toString we are converting it back to string only. So it has append, length, capacity, char add, delete, delete char add, ensure capacity, insert, length, reverse, and replace. Java string builder class. Basically, okay, now we have covered string and string buffer. Now let's talk about string builder. So basically, string builder is also similar to string buffer. More or less every property is same, but it is a not thread safe. So you cannot use it in a multi-threaded environment. Apart from that, it is okay. It is a fast, since it is a not a thread safe. So you can use it where you have to ideal situation for where you need to build a string incrementally, such as the loops where concatenating many strings. Basic method: append, insert, delete, replace to string. Basic method is almost similar to the string buffer. Okay. So basic comparison: string buffer and string builder. Thread safety: yes, no. Performance: slower, faster. Introduced in Java 1.2, Java 1.0, Java 1.5. Use cases: multi-threading apps, single-threaded apps. Okay, now let's talk about object-oriented programming concept. So basically, four pillars of OOPS: abstraction, encapsulation, and polymorphism. You know what is abstraction? This is a concept of hiding return, showing only essential features like define encapsulation. This is a mechanism for binding data attributed method that operates on a data in a single unit called class. Inheritance allows the subclasses and child class to inherit the properties and behavior. Polymorphism means many forms, allows objects of a different classes to be treated as object of a common superclass. In Java, polymorphism is achieved through overloading compile time polymorphism. For example, say ठीक है, that's fine. Advantage of OOPS over procedure oriented programming. OOPS promote code reusability. OOPS enhance code organization. OOPS support dry don't repeat yourself principle. OOPS enables faster development. So guys, thanks for bearing with me, and yeah, that's pretty much it. And I'll be uploading this video, and you will get daily update on this channel. And yeah, from 1 April onwards, keep coming and watching my daily shorts, and I will try to upgrade my video editing, video making skills, communication skills, engagement skills, as I move ahead with my journey and with this channel. So thank you guys. Bye bye.